This LOS is identify the appropriate test statistic and interpret the results for a hypothesis test concerning the equality of the population means of two at least approximately normally distributed populations based on independent random samples with one equal or two unequal assumed variances. Okay, now we're going to look at the test concerning the difference of means. So as I said, for the next few LOS, we're always going to show the different test statistics because, again, the key is to read each question very carefully, identify which test is being done, use the right formula to get the test statistic, compare the test statistic versus the level of significance, and then reject or accept. So for this type of hypothesis test, here's the formula that we need to calculate our T statistic. Again, in this case, we're dealing with the T stat again. Okay, now we're looking at the test concerning the difference between means. And this is probably one of the harder formulas to memorize. But if we work through an example practice problem, you can see it's not impossible. So when we're looking at the test statistic for a test of the difference between two population means, what are we talking about here? The null hypothesis is that the difference between the population means equals 0, or the alternative hypothesis that it doesn't equal 0. Okay? Then we can have also the null hypothesis that the difference between the population means is less than or equal to 0 versus the hypothesis that it's greater than 0. So that's a greater than hypothesis. And finally, we could have the null hypothesis that the difference between the population means is greater or equal to 0 versus the alternative hypothesis that the difference between the population means is less than 0. So that's a less than hypothesis, okay? So to calculate the T statistic in this case, in the numerator, you can see we have the difference between the sample means minus the difference between the population means in the numerator. So that's not too difficult. That's typically going to be given to you in the any type of question, but it's the denominator that's a little bit more tricky. And we can see here we have this SP squared over N1 plus SP squared SP squared over N2 to the power of the 1/2 or the square root. Okay, and what is this SP squared? They call that a pooled estimator of the common variance. And the way that we need to calculate that is N1 minus 1 times the sample variance from the first X1, from the first sample, plus N2, so that's the number of samples in the second sample, times the sample variance of the second sample, divided by N1 plus N2 minus 2, which is also how we calculate the number of degrees of freedom, is N1 plus N2 minus 2. So this formula, a little bit tricky. The numerator's not too bad. Denominator, a little bit more tricky, but I think when we work through an example, you'll see that it's not too bad. So we're going to finish this LOS by looking at a practice question. And as I said, on the CFA continuum of things, this is probably a little bit of a tougher question. You need to be up to speed on the formula 100% and to quickly look at the data that's given to you and to be able to do a couple of quick calculations and come up with the right answer. So here we're looking at independent samples drawn from normally distributed populations exhibit the following characteristics. So we can see we have two populations. There's population A and there's population B, and we've taken samples from both. So for sample A, the sample size is 25, n equals 25. The sample mean was 200, and the sample standard deviation was 45. For B, we have a sample size of 18, so n equals 18. Sample mean equals 185, and the sample standard deviation is 60. Assuming that the variances of the underlying populations are equal, the pooled estimate of the sample variance is 2,678.05. So in this case, they've given you the pooled estimate of the sample variance. You don't need to calculate it. What they're asking for is for you to calculate the test statistic. The test statistic appropriate to test the hypothesis that the two population means are equal is closest to A, 0.29, B, 0.94, or C, 1.9. Okay, we'll go through this solution fairly slowly just so that we get a good understanding. As I said, this is a bit of a tough question. With regards to the CFA continuum, probably one of the tougher questions, but we'll go through it step by step. So as I said, step number one is to read the question very carefully to see what kind of test is being done. So I put in the green box here. It says here to test the hypothesis that the two population means are equal. Okay, so we can see the hypothesis, the population mean 1 minus population mean of 2 equals 0. That's the hypothesis that the two population means are equal, versus the alternative hypothesis that they're not equal. So step number 2 then is to know that this is the test statistic, the formula for the test statistic that we're going to calculate. And in this case, you have to have that formula memorized. And so I said that's one of the probably trickier formulas that you need to memorize, but you have to do it, okay? The third thing that you need to do is that you can see this is an equality of population means. So in this case, we can make that second equation in the numerator equal to 0. The population mean of 1 minus the population mean of 2, we're doing a test that the hypothesis that the means are equal, so we can set that to 0, okay? So our numerator then is not that difficult. We can see it's the sample mean from sample A minus the sample mean from B, x1 minus x2. So it's 200 minus 185 in the numerator, minus 0, okay? Now we have to work on the denominator. So on the denominator, we recall here's the formula that we need for the denominator, but they've given us in this question the pooled estimate of the sample variance, okay? So here, remember that this SP squared, that's the pooled estimate of the sample variance. I gave the formula here as an FYI, and here's the calculation being solved as an FYI. You can see we get to 2678.04878, but they've given it to us 2678.05. So that makes the calculation a lot easier, okay? They've given that to us, so we have to divide by N1 plus the pooled estimate of the sample variance divided by N2, and then we take the square root, or to the power of 0.5. So when we solve that, and you can see the calculation then is not too bad. It's just going to take a little bit of practice. We get the correct answer is B, okay? 0.9377, and that is closest to 0.94. So that's the last slide for this LOS. Thank you.